Section 6.3, the binomial model. Finding probabilities using the binomial model. For these sessions, we're going to learn another type of probabilities, which is called binomial model. Look at this example to see what is a binomial model. Your favorite fast food chain is giving away a coupon with every purchase of a meal. So you have the coupon here. You scratch the coupon to reveal your price. 20% of the coupons entitle you to have a free burger. Okay, you do have a 20% chance to get the free burger. And then the rest of them gonna say better not next time. So first, think about it. If you do have a 20% to get the free burger, what is the percentage to get better not next time? That would be 80%, right? 100% minus 20%, which is gonna be the 80%. So now you go to this restaurant in a coupon of 10 people. And everyone's order the lunch. Everyone orders lunch means everyone gonna get the coupon. What is the probability that 4 of you win a free burger? Okay, you do have a 10 people, everyone get the coupon. And you only have a 20% chance to get the free burger. So now I want to know, these 10 people, I want 4 of them to get the free burger. Let X be the number of the people out of 10 who win a free burger. So the X represent 4 in here. Because this is what we're looking for, right? 4 of them can get the free burger. What is the probability distribution of X? In this session, we will learn that X has a distribution called binomial distribution. And this is the example for the binomial distribution. Let us look at the requirement. In order to be a binomial probability distribution, first, we need to have a fixed number of trials. Second, only 2 outcomes possible at each trial. Third, the probability of a success is the same at each trial. And then the last, the trials are independent. Okay, let's look at it one by one. A fixed number of trials. So each time when we examine a coupon, we will call it a trial. So there are 10 trials. Remember, we do have a 10 people to go to the restaurant. So we got 10 coupons. So n will be equal to 10. Only 2 outcomes possible at each trial. Remember that when you get the coupon, either you get success, means you're gonna get the free burger, or failure means better not next time. So you only have 2 outcomes, success and failure. And for this example, we are looking for 4 of you win the free burger. So win the free burger, we consider this is success. And then better not next time means like the failure. Number 3, the probability of success is the same at each trial. So since we have the coupon, every time you do have a 20% to get the free burger. Okay, so every coupon is going to be the same thing. So we say probability of the success is the same at each trial. Last one, the trials are independent, means the outcome of the coupon does not affect another one. If you have a 20% to get the free burger, it doesn't affect for the next coupon to get the free burger. So I want you guys to remember these 4 requirements. That is a binomial probability distribution. Okay, example 1. Suppose you toss a coin 8 times and count the number of the heads. Explain why this is an example of binomial experiment. Okay, so I need to fulfill these 4 requirements. And think about it, if this example will be binomial probability distribution. First, there is a fixed number of trials, right? We toss a coin 8 times, so n will be equal to 8. Number 2, each trial has only 2 outcomes, heads or tails. And since we want to get number of the head. So the heads, we consider this is success, and getting the tails, we consider this is the failure. Number 3, the probability of landing on heads is the 1/2. Okay, we're finding the probability that of the head is going to be 1/2. So every time when you flip the coins, you will have a 1/2 of the chance to get the head. Number 4, trials are independent. The first time we flip the coin, you get head or tails. It doesn't affect it for the next time when you flip the coin again. So this is called independent. Okay, right? So this is the example of binomial probability distribution. Example 2. For each of the following situations, identify which are binomial. For the one that are not binomial, explain why it is not binomial. Okay, only state the reason why it is not binomial. Number 1, record the age of a group of 20 randomly select statistics students. So for this one, do they have 2 outcomes? No, right? They're talking about record the age. Okay, you may have a different outcomes in here. So this is not the binomial. Number 2, 5 basketball players each attempt a free throw. Let X be the number of the free throws made. Think about it. These 5 basketball players, do they have the same skills? Means they do have the same percentage to get the free throw? No, right? Because making a shot is different from players to players. They don't have a same percentage to get the free throw. So this is not the binomial. Number 3, 10 cards are in a box. 5 are red and 5 are green. 3 of the cards are drawn at random without replacement. Means you pick it up and then you throw it away and then you're gonna pick another one. Let X be the number of the red cards drawn. So this one is not a binomial, right? Because the probability for each child is not independent. Because this is without replacement. So every time when you pick the card, it's going to be affected the next time when you pick the card again. So this is not a binomial. Okay, using the binomial probability formulas, I need you guys to remember all the notation for the binomial. First, n equal to number of the trials. We'll use the first example, like you have 10 people go to the restaurant to order the meal. So you do have 10 coupons, so n equal to 10. That's called number of trials. X, number of the success among n trials. And we want to see what's the probability that 4 of you can win the free burger. So X is gonna be equal to 4. And then keep in mind that the X is always in between 0 to n. Okay, so think about it. If you only have 10 coupons, that's no way you can get the 11 coupon, right? So the X is always in between 0 and n. P, probability of success in any one trial. Okay, we only have 2 outcomes, either success or failure. So like the example, we do have a 20% chance to get the free burger. So P will be equal to 0.2. Q will be the probability of failure in any one trials. Since we have 20% to get the free burger, that means we do have 80% to get better next time. Okay, so you could find the Q if you know the probability of success. 1 minus 0.2, which is going to be 0.8. And also, you could think about a P and Q, it's just like the complement, okay? Because you only have a two outcome, so you could consider the complement formula. P of X denotes the probability of getting exactly X success among the n trials. So if we want to find 4 of you win the free burger, we will say P of 4, probability that 4 of you can win the free burger. Okay, so I need you guys to remember all this notation. Shape of a binomial distribution. We flip the coin 3 times and count the number of heads. We consider the probability of success getting the head is 0.5. Okay, so we're getting the head, this is success. So getting the tails will be the failure. And then we know that will be equal to 0.5 to getting the head. So we do have this binomial distribution in here. Number of success, talking about you get the 0 head when you flip the coin 3 times. You get 1 head when you flip the coin 3 times. Get the 2 head when you flip the coin 3 times. And when you flip the coin, you got 3 heads in here. Okay, the probability of success is going to be 0.5. Okay, the binomial distribution for n equal to 3. Okay, n equal to 3, talking about the trial. We flip the coin 3 times. And the probability of success is going to be 0.5. And then the picture is going to be symmetric. Okay, imagine like I joined this point together. That's a normal distribution. And this is going to be symmetric. And then we can read from the graph that the probability of getting exactly 2 success here, getting 2 success, 2 heads in 3 flips of a coin is about, probability will be 0.38. Okay, 0.38 here. And depends on both the number of the trials and the number of success. And the distribution is always depends on the n and the p here. Okay, how many times you flip the coins, and also what is the probability of success? What is your p equal to? If n is bigger but p remains fixed at 0.5, the distribution is still symmetric. So now we're gonna increase, we're gonna flip the coins like 50 times. And the p, the probability of success, it doesn't change, still 0.5. So you can see the distribution still symmetric, okay, like the bell shape here. Okay, if we keep the n equal to 15, we still flip the coins 15 times, and this time the probability of success become 0.3. They may use the bias coin. Bias coin means I only have a 30% chance to get the head, 70% chance to get the tail. Okay, so you're gonna see when I change the p, the probability of success, my distribution is become skewed to the right. Okay, white tail is longer. So this is not the symmetric one. So the distribution for p equal to 0.3, which means that we are less likely to get a large number of success. The point is y skew. Okay, if this is not the 0.5, it won't be symmetric anymore. That would be y skew. However, even if the distribution is not symmetric, if we increase the number of trials, it becomes symmetric again. So look at this example. I still keep p, the probability of success, equal to 0.30. Okay, but we're gonna increase the number of trials. This time, I'm gonna flip the coins 100 times. The distribution here will become symmetric. Finding binomial probabilities. Probabilities can be found by hand using the binomial formula if n and x are relatively small. Okay, we could use the formula to find out the probabilities, just like the first example. We could plug in x equal to 4, n will be 10c4, and then 20% of the probability of success. we could use the binomial formula to calculate the probability. But for the homework and the exam, I highly recommend you guys use the calculator. If you guys take the P-Calculus class, you should learn the NCR already. Okay, this is the NCR. You could find it from your calculator also. And then keep in mind, x is always in between 0 to n, okay? In most application, technology that has the binomial distribution built in is used to find binomial probabilities. We could strictly using the computer. Look at the instruction in here. We're gonna do second distribution, and then we could calculate using the binomial PDF, okay? Binomial PDF. The first value will be your n, number of trials. P will be the probability of success. The value here talking about your x in here. So for the first example, if we want to find P of 4, we're gonna do binomial PDF. N equal to 10, P equal to 0.2, and then this value is talking about the 4 here. And then the binomial PDF, I want you guys to highlight the P here. This probability means we're exactly finding the some number of success. Okay, exactly at x, exactly at that point. Okay, so if you want to find P of 4, x equal to 4, so you could use the PDF in here. If you want to calculate the x is less than some value, we'll be using binomial CDF. Okay, this C is talking about you're calculating the value cumulative from 0 to x. Okay, cumulative from 0 to x. Okay, one more time. Binomial CDF function. This is calculate the cumulative probability for the value and all the values below it. Okay, I will show you guys the example and explain it one more time here. Okay, but before that, we need to know how to write down the inequalities. Okay, you guys should learn it from the algebra. What x values are implied in each of this phase? Okay, for example, more than 6. More than 6 is talking about x equal to 7, 8, 9 until n. Okay, not including the 6 here. Fewer than 5. Okay, fewer than 5. So we are looking for x equal to 0, 1, 2, 3, 4. At least 7. At least 7 is talking about x equal to 7, 8, 9 until n. Number 4, between 3 and 7, that's including 3 to the 7. 10 or more, so it's going to be 10, 11, 12 until n. Okay, example 3, finding binomial probabilities of x. According to a recent poll, 47% of Americans say it is important to control gun ownership. In a random sample of 200 Americans, find the probability that exactly 90 Americans say it is important to control gun ownership. 1 to 3 decimal space. So first, we want to check if this is the binomial probability distribution. Remember that 4 requirement? First, do they have a fixed number of trials? Yes, right? We do have in a random sample of 200. And then, do we have 2 outcomes? Yes, right? It is important to control gun ownership. Yes or no? Okay. Number 3, probability of success remains the same for each trial. Do they have a probability of success the same thing? Yes, right? Because we say 47% of the Americans say it is important to control gun ownership. So the probability of success remain the same. Last one, the trials are independent, right? The one Americans say it is important to control it, it doesn't affect for the next one. Okay, so this is the independent trials. So write it down. What is your N? What is your P? What is your Q? And what is your X? What you are looking for. You have an n equal to 200. Probability of success is going to be 47%, which is 0.47. The Q is going to be the failure. You could use 1 minus 0.47, which is going to be 0.53. And then X, exactly 90 Americans. So X is going to be equal to 90. And we want to find P of 90. Okay, P of 90. We'll be using the PDF, right? Exactly at that point. So plug it in. X equal to 90, N is 200, P is 0.47, and X is equal to 90. And X equal to 90. Okay, use your calculator. So we're gonna do second vase, go down. You're gonna see binom PDF and binom CDF. We are finding the probability exactly X equal to 90. So that will be PDF. And then 200, comma, 0.47, comma, 90. Okay, enter. So you're gonna get 0.04x2. Okay, oh, 1 to 3 decimal space, so only 0.048. Okay, example 4. A biased coin has probability 0.6 of coming up heads. The coin is told 8 times. You're gonna flip the coin 8 times. Let X be the number of heads that come up. So this is mean come up with the head will be the success. And then get the tail will be the failure. Since X is the number of heads, coming up heads is a success, okay? 1 to 4 decimal space. So first, what is the probability of getting exactly 2 of the total head? I want you guys check the requirement first. Do they fulfill the 4 requirement? Do they have a fixed number of trials? Do they have 2 outcomes? Is the probability of success remain the same? And the trials, is it independent? Okay, right? We do have a fixed number of trials with the coin 8 times. We do have 2 outcomes, head and tails. Trials are independent, alright? And then the probability of success remain the same. So good, this is a binomial distribution. Okay, right? So write it down. What is N equal to? What is your P equal to? Q equal to? And what is your X equal to? Okay, right? Finding the P and Q. And we are looking for P of 2, right? P of 2. So X equal to 2. So that would be PDF. And P and then the X. You should get 0.0413. Okay, B. What is the probability of getting at most 5 heads? At most. At most means what they're looking for. We're gonna write it as the inequality. X less than or equal to 5. Okay, at most. Not greater than 5. So this is means what we're looking for. We're looking for P of 0, P of 1, P of 2, until P of 5. So think about it. Will you use the binom PDF or binom CDF? It should be binom CDF, right? Because CDF means we calculate the probabilities cumulative from 0 to that point, okay? So binom CDF and P and then the X. Use your calculator, you should get 0.6846. On the exam, I need you guys show me this word. What you looking for? How can you put it on your calculator? What is your final answer? Okay, one more time, I need these three guys. P of what? Binomial PDF or CDF, what you plug into the value, and the final answer. What is the probability of getting more than 4 heads? More than 4 heads. What it has an inequalities? More than 4. So it will be x strictly greater than 4. More than 4. So that means we are looking for 5, 6, 7, and 8. Okay, n is equal to 8, so cannot be greater than 8. So we are looking for 5, P of 5, P of 6, and P of 7, and P of 8. For this one, we can't just apply the binomial CDF because CDF is talking about cumulative from 0 to at that point, right? Right now, they are starting with 5 to 8. So what we're gonna do? Remember one of the requirements for the probability distribution? When you add up all the probabilities, that will be equal to 1. That is from section 6.1, okay, the discrete probability distribution. Sum of all probabilities has to be equal to 1. Okay, so if we add it up, P of 0, P of 1, P of 2 until P of 8 has to be equal to 1. And now we are looking for this guy. Okay, we are looking for this guy. So I try to do the algebra here. I'm gonna do 1 subtract P of 0 until P of 4. Are you guys okay with that? Okay, make sure you understand. So this is what we're looking for, right? So I'm gonna replace P of 5 plus P of 8 for this guy. Okay, 1 minus this guy. You can see the order, they are in order. 0, 1, 2, 3, 4, and then 5, 6, 7, 8. Okay, now this is calculate the probability P of 0 until P of 4. So now we can use the binomial CDF. Okay, so I will have a 1 minus binomial CDF and P and then the X. Try to use your calculator. Plug in 1 minus and the second vars, choose binomial CDF and plug in this value. Okay, last question. What is probability of getting at least 3 heads? At least. So that will be x greater than or equal to 3. So that means we are looking for P of 3, P of 4 until P of 8. I will use the same technique as the part C here. Okay, so that will become 1 minus P of 0, P of plus 1, P of 2. Okay, right? In order 0, 1, 2, 3, 4, 5, 6, 8, 7, 8. And then same idea, that will be cumulative from 0 to 2. Okay, so 1 minus binomial CDF and P and then X. Okay, make sure you guys know how to do this example. Okay, we do have a similar question on your midterm too, similar to the example 4, A, B, C, D. Okay, example 5. I want you guys try to do it by yourself. Make sure you state the N, your P, your Q, and your X. And then what you're looking for, P of what, and then which one you're gonna use, binomial PDF or binomial CDF, what value you plug it in, and what is your final answer. 1 to 4 decimal space. Okay, what is your n equal to? N equal to 80, right? Because a sample of 80 Californians. What is your P? The number of success. That'll be 11%, right? So it's going to be 0.11. And they're looking for more than 15, right? More than 15. So it's going to be P of x greater than 15. So this means you're looking for P of 16, P of 17, until P of 80. So we're going to use the trick 1 minus, right? So 1 minus P of 0, P of 1 until 15. So you could see in order, right? 15 and then 16, 17, 18 until 80. So this guy, we could use the binomial CDF, right? Cumulative from 0 to 15. Use your calculator. Okay, right? B, between 10 and 20, inclusive lack medical insurance. So inclusive means you're going to be including 10 and 20 here. Okay, so we'll be finding binomial CDF with the 20 and then minus the binomial CDF with the 10 in here. But be careful, when you write it down, the first one will be using the 20. Okay, this is calculating the probability of P of 0, P of 1 until P of 10 and then P of 20, right? But the second one, you don't want to including the 10 here because we already find the 10 from the first one. When you subtract it, you want to take out from the P of 0 until P of 9. So the rest of them will be P of 10, P of 11 until P of 20. Okay? Okay, the mean of binomial distribution. We should be able to finding the mean if you know the N and the P and the Q, right? So I want you guys memorize the formula. The population mean for the binomial distribution will be equal to N times the P. And sometimes we call this as the expected value. If I say find the expected value, means I'm looking for the mean. Can be thought of as the number of success. We could expect if the experiment will repeat n times. As with all distribution, tell us where the distribution balance. Okay, expected value. Okay, example 6. Suppose you toss a fair coin 15 times and count the number of heads. Find and interpret the mean of the probability distribution. So we have this formula. What is your n equal to? That will be 15, right? What's a p? They're talking about flipping a coins, so either you get head or tails. So the number of success will be 0.5, right? Use the calculator, you're gonna get 7.5. So interpret what is the mean equal to 7.5. Will be expect between 7 and 8 heads in the 15 toes. Okay, expected value, which is going to be the balance point in here. Okay, so when you look at the distribution here, since the p is 0.5 here, we already talked about what the normal distribution will be symmetric. Okay, in the middle here, that will be the balancing point, which is between 7 and 8 heads in here. So this is the idea with the mean, okay, in the middle. Okay, standard deviation of the binomial distribution. We just learned the mean, right? Mean equal to n times the p. Standard deviation, the sigma will be equal to n times p times q, then square root. Or you could put n times p times 1 minus p. You know p and q are complement, right? So either you put the q here or you're going to do 1 minus p here. And what is the standard deviation? Measure the spread of a distribution, right? How spread out of the data. And this can help us approximate a range of values we could expect and a range of values we could find surprising in a binomial distribution. Okay, example. I want you guys try to do it by yourself. Okay, what's your n equal to? N equal to 500. Right? And then what is the P? Probability of success? We do have a 67% of, right? 67% of Americans believe that jury duty is part of a good citizenship. So 0.67. And what they're looking for, find the probability that more than half believe that jury duty is part of good citizenship. More than half. Okay, we do have a 500 samples. More than half is talking about 250, right? So we're looking for x greater than 250. And you're gonna use binom CDF, okay? X greater than 250 means you're looking for 251, 252 until 500. So we need to do the 1 minus, okay? You should get equal to 1. So this one is gonna be equal to 1. Why? You could just try to finding the binomial CDF with this guy. You will find it out the probability is really, really small. Okay, so when you 1 minus really, really small number is also equal to 1. Okay, B, in a group of 500 Americans, how many would we expect hold this belief? We expect, okay, that's called expected value. Remember what is the expected value? That's going to be your mean, right? So plug it in. You should get 335. That will be the mean, okay? The average value. Okay, C. Would it be surprising to find that more than 450 out of the 500 American randomly select held this belief? Why or why not? So this is talking about the usual or unusual value. They want to know 450, is it a usual or unusual number? So remember, either you're using the Z-score or you're using the minimum usual or maximum usual. Okay, remember the formula? The mean plus minus the 2 standard deviation. We already have the mean. So first, we want to find the standard deviation. Plug it in here. You should get 10.5. Now we want to find the maximum usual because the 450 is really, really close to the 500. Maximum usual, mean plus 2 standard deviation. Plug it in, you could get 356. So the maximum usual is 356. So 450 will be greater than this guy. So we know 450 will be unusual since greater than the maximum usual value. That's it.